the sandy soils, I mean, from my perspective, this is actually a really good sandy soil. Like a lot of South Australia's got much poorer sandy soils than this, and you haven't got that real white bleachy layer that you'll see in a lot of areas, I suppose. So even though it's a loamy sand, it's actually got a lot of things going for it. You know, it's got a deep root zone, the water moves through it pretty well, and holds a reasonable amount of nutrients rather than being so bleached that can't hold nutrients. But difficult to build the carbon up. And so some of the other stuff, I suppose, just having a look at the lime and the pH. So certainly that's sort of down the bottom, we're getting quite very high reactions. That layer there is still more of a sort of a high. As you come up, sort of moderate, I suppose. Still getting a bit there, but not as much lime, but still a little bit through here. That again is something we see in some of these northern mallee dunes sometimes, is you can have lime in them, which we probably don't get once we get a bit further into the wetter areas where we have sandy soils and they go acid on us. And so again, pHs are all pretty alkaline. Well, you'd have to, I mean, with this one to make it acid, you're going to have to just get rid of all that lime. And I'm not sure it's through. Yes, even there's a bit. Put on 250 units of N using SOA though every year. Yeah. Around your drifters, you're going to have a. You're probably right. So what are you putting out? 250 kilos. What form of N are you putting out? Nigel, he's talking, but well, I was just saying there is a bit of lime right through the profile here, but. And certainly have seen citrus suffering from magnesium deficiency in the Riverland, where they acidify too much. But on this one you're a bit buffered because it's got the low level of lime through it just here anyway. But that's right. If it's 1% lime, you've got what, 14 tonnes. So you've got a few years yet. So with this one, I suppose. So Jeff, when he did his water holding, he actually put the root zone down even a bit deeper on this one to 90. And came up with a higher, 100 mil water holding capacity compared to, I think it was about 80 down there, and the readily available at 56. So even though it's sandy soil, it's got quite deep root zone. The chemistry, pHs are all are alkaline without being strongly alkaline, like the one down the hill, down the bottom. The salt levels are good. The organic carbon was back to 0.35 here, so I suppose that's reflecting. Naturally you would have had lower carbon to start with, and even though it's added a bit, it's not staying in it. Phosphorus buffering index of 23, so again, almost at that stage where it would leach a little bit of P, I suppose. And the coal well P is quite low, as well as I suppose sulphur and copper are a bit marginal too. But no real chemical toxicity showing up, I suppose, in terms of the cations or the salt or the ESP or the boron or any of those things that we saw down the bottom of that one, I suppose.
Dig deeper to find them.
And as I've said, certainly when we've looked at things like Blanchetown clay, it is just deeper. It's just down deeper. But you do find it underneath if you go deep enough. In your notes, I also wanted to talk, the last hole I was meant to talk about carbon testing, which I forgot. So there's a page in the notes, which is that page there, I think. And one of the challenges, I suppose, with testing, measuring carbon and carbon accounting in calcareous soils like the one we had down there, is what test do you use? What we've found, I suppose, is the Walkley Black test, which is the old test that people use for organic matter, probably only measures 80–90% of the totals. And it's a repeatable test. It's a good test, but it doesn't measure everything there. So a lot of the people are moving to what they call a combustion test, I suppose, or a LECO or JUMIS, where they basically burn the carbon out of that, and they measure the carbon that way, and it will measure everything that's in there. But the problem is that the calcium carbonate also does the same thing. So what you'll find if you're I think APL's getting their head around it now as a lab, but some of the other labs interstate basically just do those combustion tests as standard because they don't have calcareous soils in their district. So if you get your testing done through there, you can get an inflated carbon figure because they're basically burning all the lime as well and chuffing that up. So I suppose where it seems to be going with APEL is that they're now looking at doing the total combustion test. They're also doing a test to measure how much calcium carbonate's in that sample and then subtracting them off to give you like a total, so you end up with a total organic carbon, I suppose, which is what you want for any carbon accounting purpose. Sounds a bit confusing, but anyway, it's just something to be aware of on calcareous soils, that test, understanding that test and what you're doing, and the lab that's doing it, I suppose, making sure they do a test which is useful, I suppose. And as you were talking before, if you really want to increase your carbon content in the calcareous soil, you just change your test halfway through.
Exactly. You sequestering already sequestering carbon.
Yeah. But there's certainly APEL's starting to get their head around it now, and I'm hoping other labs will as well. But a lot of the interstate labs don't do calcareous soils, do they? So they just do don't pick it up. Also did mid-infrared. There's 2 mid-infrared ones that we did here, which is again is a sort of a short test, an infrared scanning technique, which you can get a whole range of things done, but a lot more cheaply. And they're in here as well, but they're okay, but you wouldn't, I don't know whether you'd bank your carbon accounting system on them. You'd know better than me, would you? They're a little bit rubbery when I look at the figure. Well, it depends who I believe, which one's right, I suppose. But yeah, I'd sort of...
The interesting thing with infrared is that a measurement of inorganic carbon by infrared is probably more correct than anything you would calibrate it against.
Yeah, well, I probably should get you to comment on what you say for calcareous soils, what the best test is going to be.
We still stick, so I work at PIRSA in the carbon lab, we still stick by LECO for total and pre-treat with sulfurous acid to remove carbonate.
Yeah.
There are a few soils where the sulfurous acid just doesn't cut it, that's sulfurous, not sulfuric, in the bolt that goes in the LECO. The trouble with washing is no matter how meticulous you are about centrifuging and getting that bulb and the pellet at the bottom, you're always going to lose some of your organic carbon if washing it off, even with fairly dilute acid. So actually having it in the boat means you're not losing any material, but the trouble is you are constrained by what you can use to get rid of the carbonate. The trouble with your alternate is you measure inorganic carbon and subtract that from total carbon. But for really calcareous soils, subtracting one big number with some uncertainty from a slightly bigger number with some uncertainty, and getting a very small number with a lot of uncertainty. The trouble is they all just measure CO2 by infrared, and whether the CO2 comes from the carbonate or from burnt organic matter is the instrument doesn't care.